if something is irrelevant, we should not teach it. If it is not coming under the learning objectives, then why do we teach that? So everything should be very relevant. So, course content, then learning process. You have defined the learning objective, you have created the course content, then learning process. How to assimilate those ideas? How to do the learning? Okay? So learning process is also very important. What ways need to be adopted for any particular course? Then learning assessment. The student used to learn something and that assessment need to be done. Learning outcome. Okay? On the basis of assessment, we will define what was the learning outcome. Okay? Obviously, grading and other things, those are some high-level constructs. Okay? Whether we are giving 100 marks, 70 marks, 80 marks, whatever it is. So these are some grading, the students' grading. So obviously, grading is done on the basis of learning outcome. If they have achieved their goals, it's fine. They are good. If they could not achieve, we have to just segregate the class of the students. It is not necessary that every student should be segregated in discrete way. Means the way like we are using the absolute marks. In absolute grading, every student may have different marks. Okay. But here in IIIT Allahabad, generally we use to follow the relative grading. Means we use to just segregate the students in only 5-6 classes, that's it. Okay, maybe starting from A plus A, B plus B, like that. Even if you are giving some marks, these are not the actual marks. Okay, these are the marks derived from the relative grading. Okay, so learning objective, course content, learning process, learning assessment, outcome and grading. These are the basic components for teaching any course. Learning objectives must be very clear, fixed and measurable. Okay. Clear, fixed and measurable. Once you have decided your learning objectives at the beginning of the course, you should not change or be not used to alter in between. Because everybody will be tuned as per those objectives. So it should be clear, fixed and measurable. Course content should support the learning objectives and should be very clear. Okay? We want that our students should be able to design 8-bit ALU, which is very elementary ALU. Suppose having only 16 functions. Then what is the fun of teaching the most recent, latest state-of-the-art technology which is being adopted by various manufacturing agencies, isn't it? So that's why you need to define your learning objectives and then course content should be decided. Learning process should be always iterative with feedback. In the first session also, there was a question, means while interacting with the students, a continuous feedback is necessary. The feedback must be given either by the teacher itself or by the representative of the teacher. So teachers are our representative, that's why per class there are only 25 students. So every team needs to interact with 12 and half students in 2 hours. So it's sufficient time. Okay? In 2 hours you can interact with 12-13 students. So every student used to get sufficient time. Okay, so this way we are just increasing the contact hours. Normally in lecture we used to say, okay, this is contact hour. So 100 students are studying in a class. How can you say that every student is getting 2 hours? No. Personally they are not getting 2 hours. But we used to say this way. But in tutorials and practicals, they are getting. In IIIT system, at least for this particular course, they are getting. Okay? So it will be sometimes assignment in the practice session. And we find the students are not able to do. So immediately you can sample. Everybody is not doing good, it means there is some flaw. So we used to say that okay, can we repeat this exercise? Similar exercise, not exactly the same exercise, but similar exercise with the same level of toughness or easiness, whatever you say. Okay. And then we used to tweak in between. So throughout the semester, many times we can tweak this way, but we are not going to tweak with the learning objectives. Okay? Here, it is not necessary for learning process. Sometimes what happens, we assess for 10 components, but it is not necessary to consider all those 10 components. We used to count only for 6 components. Why? Because throughout the semester there may be certain issues with the students. Okay. It is very probable that every student will face some problem for all the courses, at least for some time. It may be very few, maybe 1, 2 or 4 instances throughout the semester, but it happens. In case of the continuous assessment, it's very probable that they will miss the assessment. If they are missing the assessment, obviously they will be left behind. So they should be provided a chance. So we used to follow this way. We are quite adaptive in this way. Then learning assessment, yes. In the first part of the session, today's first session, formative, summative with sufficient objectivity and subjectivity. What do you mean by objectivity and subjectivity? They are predefined. On the basis of some mathematical quantity, you can decide whether this is good or bad. Okay? And what is the subjectivity? If you interact with the student, sometimes you are not able to extract what is this student. Okay? So obviously, you give something. Suppose I just circulate a page of paper and I say you just write 200 words on nationality. Say, after reading those documents, I can assess. I can get an idea what are your thoughts, which may not be reflected in your personality or in objective assessment. Okay? So something to expect. So that's the formative and summative with sufficient objectivity and subjectivity is necessary for this particular course. Then, learning outcomes are compared against the predefined expected threshold. So normally in traditional teaching, it is a mark. How many marks you are getting? This is general trend. If you are getting 100% marks, you are the best. 90%, 80%, 70% this way. But even it is not necessary to define by the marks. And if you are defining by the marks, then holistic assessment should be embedded into those marks. Isn't it? All objective, subjective assessment with formative and summative processes should be included into those marks. These marks are not merely the marks, but entire personality of the student throughout the semester which he or she is going through has been just fitted into those marks. Okay. Then here it may be relative with absolute normalized with outlier factor. So normally what happens? We 3 teachers used to teach this course. In every class, suppose the topper is there, then there is a single topper. And there is a huge gap between the topper and the next student. So we assume this topper as an outlier. If we compare all the students with this topper, what will happen? How this gap will be filled? This gap will always remain there. This cannot be filled. Okay. Just to observe the average behavior of the class, we need to remove this outlier. And that is exactly done in any data science or data analysis problem. So outliers has to be removed. Similarly, there may be some absent absentees in the assessment. Like they have left in between. So obviously they are going to get 0. If you consider the 0 and take the average, your average will be affected. So why to have the effect of that person which is actually not in the class? So this will be used to remove some outliers from the top and the bottom, and then try to capture the average behavior of the class. So normally relative with absolute normalized. And what happens? There was a question in the morning. Suppose 3 teachers are teaching a course. Okay. And for one teacher, the range of marks, if the teacher is liberal, obviously he will be liberal for all. You remove the outliers. Even if he is biased, remove the outliers. So if he is liberal, will be for all. His stuff will be for all. So for liberal teacher, what will the marking pattern? Maybe 99 to 70. 99 to 70. And for tough teacher, it is from 70 to 30. Then how to mix? So normally, we assume that there is a sample size is quite large. It is 100. So some sort of randomness is here. We assume there is a Gaussian curve for all the distribution and mix the Gaussian. Mixture of Gaussian is again Gaussian. We know very well. Okay. But still, the range is more. Here the range is less. Then what we do? You simply normalize to the highest marks, provided the outliers are removed. Then what is the range for first class? It is between 0 and 1. Isn't it? And what is the range for class 2? 0 and 1. And all the ranges are between 0 and 1. And then mix it. Because the distribution was always Gaussian. It was already Gaussian. Mix this, again it is Gaussian. Okay, and then decide. You take the average of these 3 toppers. Okay, and then decide what should be the maximum marks. This average may be replaced with the maximum marks, multiply with the average, and then it can distribution. So now whether this is normalized or not. We are drawing a block diagram of some architecture. Got it? Or draw a block diagram of ALU. Got it? So what is this? This is basically high level understanding that there are these very blocks. And what is the functioning of those blocks? So obviously, high level understanding is necessary. So the student should have the high level understanding of the rule of assemblers, instruction set, and hardware. Should be able to use the instruction set. The next one is they know, then can they use, then how to enable the students so that they can use it. So should be able to use the instruction set architecture effectively by assembly language programming. This is your learning objective. So what made it a question? You write an assembly language code to multiply these 2 numbers. You write an assembly language code to find out the sign of a number. Isn't it? They understand, but can they use? So this is just a skill. The first one is just fact. Should be able to understand the various arithmetic, soft and hard processes for addition, subtraction, multiplication, and division. For integers and floating point numbers, the level of complexity is moving high and high. Should be able to design various hardware components. They should know the algorithms or methods, and they should design or they should code. Should be able to design various hardware components like arithmetic and logic circuits along with rules and design parts. Everything is known to all teachers, all computer science teachers. The students should understand the memory organization hierarchy and other things. The student should understand the performance criteria, benchmarking, optimization, and its role in efficient design and use of process. Okay? Until they know the benchmarking, they cannot compare the performance of various designs, and they cannot think of any improvement. So we need to give sufficient emphasis on this particular topic. Although this topic seems very irrelevant, but obviously entire computer organization architecture depends upon this particular objective or this particular content. So that's why we used to refer and see pattern for this topic. That is different. Okay. And then at last, the student should be able to design. This is the ultimate objective of the course. At last, the student should be able to design and build a minimum instruction set architecture and process its organization, propose its organization and entire system. Means how to design. At least some very small, okay, area we used to call as processor, the main component of the processor, and how to interface other things. So this way we used to define the course objectives. Obviously, we need to give the course outline. So these are some directive things so that the student should be able to understand. Okay. So overview of computer organization architecture, data representation, ISA, computer arithmetic, memory organization, IO organization, computer performance assessment and enhancement. It means with the help of these course outlines and study in detail, then only you can achieve the course objectives. But else course objectives cannot be achieved. Yes. Well, pardon. Which one? Course objectives means whatever is expected. Whatever is expected from the student at the end of this complete studies, whether the students are able to do this thing or not. Yes. First define your objectives, then choose the content, and then choose the process. Okay? And then do every other things. Like in this particular course, sorry. Yeah. So textbooks, obviously you need to refer some textbooks. So we used to follow this NSE pattern. And two aspects for completing the course. One is designing, the second is the use. How to use it very effectively. Both the things are required. So we have this fixed programming using mass. There is some simulator. We are not doing any hardware programming. Assembly language programming we are not doing on the kids. So simulators are there, obviously just to brush up the concepts. They can install on lab computers when they come for the assessment. And at the same time, the same simulators are installed on their own PCs. So whenever the assignments are floated, they cannot say that we could not solve it because they could not come to the lab. It is not necessary. Even if they are not coming to the physical space of laboratory, it is expected that they have to do this. Maybe at their room itself. This is design using logic so that they should be able to design some components. Maybe add, subtract, multiply, divider, many other things. Even the ALU itself at the last. Obviously, there are some references. Classroom lecturing philosophy. This may be different for all the teachers. Typical time is 60 minutes for 1 hour. Assumption. What are the assumptions before we start the class? The students are diverse in terms of region, past, gender, family background, intellectual capabilities, and other factors. Everybody may agree with this, and this is true up to some extent. All the students are having the smartphones and Wi-Fi connectivity nowadays. We cannot stop them using the smartphones in the class. So, is it possible to use these distractors in some constructive way? We were facing this issue. Earlier, what we were doing, we used to check. और उनसे बोलते थे, just keep your mobiles at the table. But for how many students? Every day you need to do this exercise. Then we thought of something different. Okay, they themselves are having some distractors. Can we use these distractors? So we'll discuss. Typical lecture time attention curve. This is my philosophy. This is interesting. Okay. So at x-axis, time, and at y-axis, level of attention. Level of attention of the students. Percentage means total percentage of the students. I mean, level of how many students are attentive, yes or no. Okay? So initially what happens? When we enter into the class, what is general observation? Some front row students are very attentive, isn't it? And we must be discussing something first. As I was it is very attentive. You enter in the class, you will find that roughly 55-60% students are attentive. Not more than that. Everybody is not attentive at all. Okay. Then you start speaking something. Initially, students will start watching you, observing you. Okay? And then level of attention may go up to 95%. Means 95% of the students are ready to listen whatever you are going to tell them. Then time will pass. Then what happens? At 20th minute, level of attention goes down.